Hi everyone, just wanted to take a moment to talk a little bit about how to solve systems of equations by elimination. We'll go through about four examples that kind of show some of the different levels of elimination that you're going to have to deal with. And we'll also just talk a little bit about when you would kind of choose elimination. So this is the third and final method of solving systems of equations that need to know. So we have gone over graphing, which when we're dealing with things on a computer, that's not terribly hard because we do have things like Desmos. But by hand can be problematic, especially with larger numbers or with numbers that have an intersection that isn't quite nice. Additionally, we've gone over substitution, which was really nice when you had something in standard form and another thing in point and slope intercept form. And now we'll go over elimination, which tends to be really helpful when you have two equations that are in standard form. Again, you can choose whichever method. Any method will work for any system of equations. But that being said, um, there obviously are situations where certain ones are easier. In particular, this first example up here, this is a really, really good one for elimination. The reason behind that is these are already going to cancel. So when you add them together, that cancels. You get 7x equals negative 35. X will equal negative 5. And then it's a simple plug in, right? So we get 5 plus 2y equals negative 15. 2y equals negative 20. So I would get y equals negative 10. All right, so I got the point, negative 5, negative 10. And as a reminder, that is if you were to graph it, that would be the point of intersection. And again, if you were to do substitution, you would also get the same answer. It does not matter. Additionally, I do want to point out, if you go through these steps and you get something that says 5 equals 5 or 6 equals 6, that would be the case again where there's infinitely many solutions. And once again, if you go through this and you get something like 3 equals 2, that would be the no solutions. So just like the substitution, when that happens, you have those special cases. All right, so now we can look at this one. This one's still not terrible for elimination. And the reason it's not that bad ultimately comes down to the fact that even though nothing is directly going to cancel, you can see that if I just change the signs of everything on one of the equations, the x's are going to cancel. All right. So I'm just going to multiply everything here by negative 1. And that's the same thing as changing all the signs. That'd be also the same thing as subtracting. Right? So when I combine them, the x's are going to cancel. I'll get 5y equals 20. Y will equal 4. Now I'm going to plug back in up here. I get 3x minus 3 times 4 is 12 equals 18. 3x equals 30. So x will equal 10. All right. So again, I would have 10, 4 as my point of intersection that I would get if I were to graph it. All right, now we get to some slightly more complicated ones. As you can see, the ones down here, if I add them directly, nothing is going to cancel. If I just were to subtract them, nothing is directly going to cancel. However, if we look at the negative 4 and the negative 7, that doesn't really help us, right? In order to get like a negative 4 to become a negative 7 or to become a 7, you'd have to multiply by a fraction. Similarly, you'd have to multiply by a fraction so that the 7 would become a 4. But we have a 5 and a 10. It's super easy to go from 5 to 10. I just need to multiply everything by 2. And in this case, because I want them to cancel out, I don't want to multiply this one by 2. I want to multiply it by negative 2. So that way it would cancel with this one down here. All right, so I get negative 10x. Negative 2 times negative 4 is positive 8y equals 18. All right, now I'm going to add these ones. That cancels. We get y right off the bat. Isn't that nice? Negative 4. All right, so I get negative 4 when I add these two together. Now, it does not matter which of these I plug into. Once again, I'm going to pick the top one because it has smaller coefficients, but it does not matter. So I'd have 5x minus 4 times negative 4 is negative 9. So I get 5x is going to equal positive 16. That's going to equal -9. All right. When I subtract that, I'm going to get 5x equals -25. So x is going to equal -5. All right, so I get -5, -4. Again, not terribly hard, but it does require a little bit more work than some of the other methods, but that's fine. I think we ultimately still can manage something like this. And then we get to the last one, which obviously is going to be the most difficult. Not necessarily in terms of computation, just in terms of getting them to cancel something out. So I have a 2 and a 3 and a -5 and a 2. Now, you could multiply everything by a fraction. That's fine. I'm not going to stop you, but it does introduce fractions. So if you want to get rid of these and make them equal each other, get something to cancel, I should say, but you don't want to multiply by a fraction, you're going to have to multiply both equations by something. And what you'll do is you'll multiply by the coefficients of the of the other equation, right? So if I want to get it so that these two cancel out, the y's cancel out, I would need to, in this case, multiply by 5. And this side, this one up here, I have to multiply by 2, right? So that would give me a -10 and a 10, all right? If I wanted to cancel one of these out, I would need to multiply the top by a 3 and the bottom by a 2 and make one of them negative. It doesn't matter which one. But ultimately, all you're going to do is you're going to look at the opposite equation, look at its coefficient, and then multiply the other equation by that coefficient. All right, so I'm going to multiply this one by a 2. Now I'll multiply this one by a 5. So I get 4x minus 10y equals 22. And I will get 15x plus 10y equals 35. Right? That's going to cancel out. I get 19x equals, what's this, 57? So that would mean x would be equal to 3. Okay, now again, it does not matter which one I plug into. I'll plug into the bottom one, why not? So 9 plus 2y equals 7. You heard me make that side just because there's not really one that's slightly easier. I mean, I went with the bottom one because it's a 2 instead of a 5, but there's really no difference. So minus the 9, I get 2y equals -2. Divide by the 2, I get -1. So I would ultimately end up with 3, -1, and there you have it. Now, something like that is probably going to be one of the more complicated ones, but most of the time you'll kind of see somewhere in this vicinity where you're either just multiplying by a negative or you're multiplying by something like a 2 or a 3. Those are the most common ones you encounter that you'll actually do elimination. To be honest, elimination in terms of day-to-day operations might not be the most useful, but it is really good and really quick for certain ones. It's actually very useful when you get into algebra 2 and have to deal with like 3 systems of equations. So that's why it's important to get a hang of it. But anyway, that's all. If you have any questions, please let me know. Have a great day.